Saturn has always been one of the most enigmatic giants of our solar system, a colossal world wrapped in golden clouds and surrounded by icy rings that make it look more like a cosmic artwork than a planet forged by natural laws. But as our telescopes improved and our spacecraft ventured deeper into the unknown, scientists discovered that Saturn hides an even greater mystery, one that seems to defy everything we know about planet storms and the rules that govern fluid atmospheres. At the very top of this gas giant, swirling around its north pole, sits a geometric structure so precise, so mathematically perfect, that it seems almost impossible, a gigantic storm, shaped exactly like a six-sided polygon, the hexagon. When the Voyager spacecraft first photographed it in the 1980s, scientists thought it had to be an illusion or an imaging error. How could a storm on a planet made entirely of gas arrange itself into a perfect geometric shape more than 30,000 kilometers wide? How could something so natural look so engineered? The idea of a storm forming straight lines and sharp angles goes against everything we observe on Earth, where hurricanes form spirals and cyclones twist into chaotic shapes dominated by turbulent currents. But the images were real, and later missions, including the Cassini spacecraft, confirmed it over and over across different decades, seasons, and lighting conditions. The hexagon is not temporary. It is not a coincidence. It is a stable, enduring structure that has existed for at least 40 years, and perhaps for centuries. The more scientists studied the hexagon, the stranger it became. Its sides are almost perfectly straight, each measuring thousands of kilometers. Its edges meet at precise angles, forming a shape that looks like it was carved by a cosmic architect. Inside the hexagon, winds reach speeds of 320 kilometers per hour, swirling around a central vortex, an enormous hurricane-like eye, sitting exactly at the North Pole. And yet, despite these violent winds, the structure remains stable, holding its shape over decades without collapsing or deforming. Something is maintaining it. Something that acts like a natural resonance, locking the winds into this repeating geometric pattern. Cassini's close flybys provided even more shocking details. The colors inside the hexagon varied dramatically over time, shifting from a bluish hue to a glowing golden color as Saturn moved through its seasons. This change in color hinted at deeper processes involving sunlight, chemical reactions, and the dynamics of Saturn's upper atmosphere. It was as if the hexagon itself responded to the cosmic environment, adapting and transforming as the planet orbited the sun. Every new observation added complexity, suggesting that this structure is not just a storm but a layered phenomenon, a kind of atmospheric machine powered by the physics of rotation, fluid motion, density waves, and perhaps variables we do not yet understand. One of the most extraordinary discoveries is that the hexagon rotates at almost the same speed as Saturn's internal radio emissions. This suggests that the storm might be connected to deep layers of the planet, far below the visible clouds. Unlike Earth, Saturn doesn't have a solid surface. Its atmosphere blends gradually into immense layers of metallic hydrogen and extreme pressures. The hexagon might be a window into Saturn's interior, a surface-level expression of powerful forces buried deep within the planet. The idea that a weather pattern could reflect the rotation of Saturn's interior is almost mind-bending. It means the hexagon isn't just a cloud formation, it may be a manifestation of the planet's hidden heartbeat. Scientists tried to recreate the hexagon in laboratories on Earth, using rotating cylinders filled with fluids. When they spun the fluids at precise speeds and introduced jet streams with specific instabilities, polygons began to form, sometimes three-sided shapes, sometimes 5, 6, even 7. The six-sided pattern matched Saturn's conditions most closely. These experiments revealed something extraordinary. A polygonal pattern can form naturally in a rotating fluid under the right conditions, but it is incredibly sensitive and difficult to maintain. Yet Saturn does it effortlessly, on a scale no human experiment could ever match. Seeing a hexagon in a lab is one thing. Seeing one swirling around a gas giant for decades is something else entirely. This raises a deeper mystery. Why a hexagon and not another shape? Nature seems to favor hexagons in structures where efficiency and stability matter. Snowflakes, honeycombs, certain crystal formations. A hexagon allows for equal distribution of stress and optimal packing. Could Saturn's atmosphere be self-organizing in the same way, finding the most stable pattern for the jet stream that encircles the pole? Or does the shape emerge from deeper resonances within the planet, becoming a harmonic expression of Saturn's internal dynamics? It is as if the atmosphere is solving a complex mathematical problem and displaying the answer in the form of geometry. The hexagon becomes even stranger when we consider that it is essentially a standing weave pattern that maintains its shape, even as the fluid moves through it, like ripples frozen on the surface of water. In this case, the water is Saturn's atmosphere, and the ripples are thousands of kilometers across. The storm inside is constantly churning, but the edges remain fixed, holding the six sides in place. This is unlike anything on Earth. Even Jupiter's Great Red Spot, although huge and ancient, is turbulent and ever-changing, with its edges shifting over time. Saturn's hexagon, by contrast, is a masterpiece of stability. The mystery deepens further when considering the powerful jet stream that forms its outer boundary. This jet moves much faster than the interior winds, creating a dramatic shear zone where two layers of the atmosphere interact. Some scientists believe this boundary acts like a barrier, trapping energy inside and preventing the hexagon from breaking apart. Others suggest that subtle temperature gradients at the pole might help maintain its structure, but the truth is that no theory fully explains why the hexagon is so stable, so long-lasting, and so geometrically perfect. One of the most striking features captured by Cassini is the vortex at the center of the hexagon. This central storm resembles a hurricane, complete with an eye, spiraling clouds, and vertical motions that extend into Saturn's depths. But unlike hurricanes on Earth, which feed on warm ocean waters, Saturn's polar vortex forms in an environment with no liquid surface and freezing temperatures near -180 degrees Celsius. The energy source is entirely different, likely tied to the planet's internal heat and the strange physics of gas giant atmospheres. The vortex is massive, spanning more than 2,000 kilometers, and its swirling motions create mesmerizing patterns of clouds that appear almost surreal. As Cassini dove closer to Saturn during its final missions, it provided unprecedented details of the hexagon's structure. Scientists observed multiple layers of the storm, each with different speeds and behaviors, stacked like an atmospheric layer cake. Higher altitude hazes responded more to sunlight, while deeper layers seemed influenced by Saturn's internal heat. Together, these layers created a three-dimensional structure far more complex than anyone expected. The hexagon is not simply a flat shape, it is a towering, multi-layered phenomenon extending deep into Saturn's atmosphere. And yet, for all we know, the hexagon may hide more secrets still. Saturn's polar regions are incredibly difficult to observe from Earth due to the planet's tilt. For most of Saturn's 29-year orbit around the Sun, one pole is in darkness while the other is illuminated. The hexagon only becomes visible when the North Pole is bathed in sunlight. This means we may have missed earlier variations or cycles in its behavior. What if the hexagon grows, shrinks, or changes shape over time? What if deeper patterns exist beneath the visible layers? What if it interacts with Saturn's magnetic field in ways we cannot yet measure? Even the colors of the hexagon pose questions. During the early years of Cassini's mission, the hexagon looked bluish, likely due to the scattering of sunlight through methane-rich air. As spring arrived in Saturn's northern hemisphere, the sunlight triggered chemical reactions that produced a golden haze. The transformation was smooth, yet dramatic, almost like watching the planet breathe through its seasons. This color shift hints at a dynamic interplay between sunlight, atmospheric chemistry, and the internal dynamics of the storm itself. The hexagon is not just a stable structure, it's a living system, evolving, responding, and interacting with its cosmic environment. Some researchers have suggested that the hexagon might be part of a larger atmospheric pattern that encircles Saturn, perhaps linked to waves traveling around the planet. These waves could resonate at the pole, creating a standing pattern that manifests as a hexagon. Others believe the structure might be influenced by Saturn's rapid rotation, which creates strong Coriolis forces that shape atmospheric currents. But even with these theories, the precision of the hexagon remains difficult to explain. A slight change in the planet's rotation or atmospheric density should distort the pattern, yet it does not. And so the hexagon continues to fascinate, a cosmic anomaly rotating silently in the distant cold of the solar system. It represents the perfect blend of beauty and mystery, a place where the laws of physics create something that feels almost designed. For decades, humans have tried to understand it, sending probes across billions of kilometers, building models, conducting experiments, and revisiting data again and again. But the storm resists full explanation. It reminds us that even within our own solar system, there are phenomena that remain deeply mysterious, pushing us to question our assumptions and expand our understanding of how planets work. As researchers continued to analyze Cassini's treasure trove of data long after the spacecraft's farewell plunge into Saturn's atmosphere, the hexagon transformed from a simple atmospheric curiosity into a profound cosmic puzzle that tested the limits of planetary science. The more physicists simulated its behavior, the more they realized that the hexagon is an exceptionally delicate balance between chaos and order. It behaves like a geometric cage trapping a vast reservoir of energy, shaping the violent motion of gases into a nearly perfect polygon that hardly wavers even as Saturn rotates beneath it at incredible speed. It is almost paradoxical, turbulence creating clarity, a storm creating structure, chaos generating geometry. But perhaps what makes the hexagon so mysterious is not simply its shape or size, but the way it moves. Saturn spins at an astonishing pace, completing a full rotation in just 10.5 hours, despite being enormous. This rapid rotation produces fierce atmospheric bands of alternating winds, some blowing eastward, others westward, creating jet streams that circle the planet in parallel stripes. Near the equator, these bands are relatively predictable and often resemble Jupiter's colorful belts. But as one approaches the poles, these bands become unstable, twisting and interacting in complex ways. Somewhere in the northern region of Saturn, all of these competing forces converge, locking into a pattern that no model fully explains. The hexagon does not drift, nor does it lag behind the planet's rotation. Instead, it maintains a curious synchronization with Saturn's deeper layers. Scientists noticed that its rotational period closely matches the rotation of Saturn's magnetic field, suggesting the storm might be anchored to something far below the visible cloud tops, something deep inside the planet beneath layers of fluid, hydrogen, and unimaginable pressure. This connection, still tentative, hints at a link between Saturn's atmosphere and its interior, a bridge between its visible storms and its hidden metallic heart. The storms that form the hexagon's sides are powerful, high-speed jets that seem to collide and slide past one another, producing waves that bounce around the polar boundary like ripples trapped inside a giant bowl. When these waves interact in just the right way, they form repeating patterns. But while waves on Earth rarely settle into perfect polygons, Saturn's enormous scale and uniform atmospheric composition allow these resonances to unfold in ways impossible here. Saturn's atmosphere is smoother, deeper, and more uniform, giving rise to phenomena that feel almost alien. Cassina also revealed that the hexagon casts subtle shadows during certain seasons, revealing that some parts of its structure rise above the surrounding clouds. This elevation suggests that the hexagon isn't a flat pattern drawn on Saturn's surface but an actual physical structure with vertical walls shaped by atmospheric currents. Imagine a six-sided mountain of wind, thousands of kilometers wide, pressing upward into the stratosphere, a colossal wave frozen in place, carved entirely out of gas. Yet even this image barely captures the reality. The hexagon spans a region comparable to the width of 4 Earths placed side by side, and its winds follow curved paths that precisely match the edges of the polygon. From above, it looks almost too perfect, a shape that could be mistaken for a cosmic emblem or a symbol imprinted onto the planet itself. For centuries, humans have associated geometric perfection with intelligence or intention. But here, in the distant cold of the outer solar system, geometry arises naturally from nature's own equations, as if the universe is revealing one of its hidden signatures. Some scientists speculate that the hexagon may be tied to atmospheric oscillations, similar to those that occur on Earth, such as the quasi-biennial oscillation regular shifts in wind direction in our equatorial stratosphere. But on Saturn, with its greater size and faster rotation, such oscillations could become amplified into massive, planet-spanning waves capable of forming large-scale geometric patterns. If this is correct, the hexagon might be part of a much larger atmospheric rhythm that spans decades or even centuries. Another theory proposes that the hexagon arises from a phenomenon called Rossby waves, large-scale waves found in rotating fluids. On Earth, Rossby waves appear in oceans and atmospheres alike, shaping weather patterns and jet streams. On Saturn, they might behave differently due to the lack of solid boundaries, and the planet's enormous rotational energy, creating shapes far more stable and symmetric than anything seen on Earth. In some fluid simulations, Rossby waves naturally settle into polygonal structures if the conditions are just right. The hexagon could be the outcome of such a perfect arrangement. It's even been proposed that the hexagon may represent a kind of atmospheric resonance chamber where waves ricochet endlessly within a confined region, reinforcing one another until the system locks into a stable pattern. If the frequency of these waves aligns with the rotational speed of the planet, the result could be a geometric shape that persists indefinitely. It's similar to how a musical note can cause a glass to vibrate at just the right frequency, except here the glass is a gas giant, and the note is a storm thousands of kilometers wide, humming in harmony with the planet's rotation. Despite all these theories, none offer a complete explanation. The hexagon remains elusive, resisting simple categorization or definitive modeling. It is a reminder that even with all our technology, our spacecraft, and our understanding of physics, the solar system still contains phenomena that push beyond our current scientific reach. The more we learn about planets, the more they humble us. And then there is the question of time. The hexagon seems timeless, as if it has existed long before we discovered it and will continue long after. Every decade of observation shows it maintaining its crisp edges, never collapsing into a spiral or becoming distorted beyond recognition. On Earth, even the most stable atmospheric features change constantly. Jet streams shift, storms dissipate, and climate patterns evolve. But on Saturn, the hexagon stands resilient, as if insulated from the chaos that typically governs atmospheric behavior. The color changes observed over the years also suggest a dynamic interplay between sunlight and the storm's chemistry. During Saturn's long winters, the pole falls into complete darkness for 14 years, bathing the atmosphere in frigid temperatures. Without sunlight, the chemical processes that produce photochemical haze slow dramatically, revealing deeper blue layers. As sunlight returns in the spring, the haze thickens, turning the hexagon golden. This cycle paints the hexagon with the rhythm of Saturn's seasons and atmospheric canvas that shifts hues based on cosmic timing. While Cassini studied Saturn up close, Earth-based telescopes continued monitoring the hexagon from afar. The Hubble Space Telescope provided stunning long-term observations, capturing the slow, graceful color transition as sunlight returned to the northern hemisphere. These images allowed scientists to watch the hexagon awaken, as if the planet itself was emerging from a long, cold slumber. Yet every observation, every cloud shift, every color change, every contour of the vortex only deepened the enigma. The hexagon might be stable, but everything around it seems to evolve. Saturn's rings cast shadows that drift across the planet's atmosphere, cooling different regions unevenly. These temperature gradients influence the winds, which in turn affect the hexagon. The storm is not isolated. It is a participant in a vast atmospheric ballet where every movement influences the next. Another surprise came when Cassini captured infrared images that revealed heat signatures deep within the storm. Far below the visible clouds, heat seemed to be rising from Saturn's interior, contributing to the energy that fuels the vortex. Saturn emits more heat than it receives from the Sun, meaning much of its atmospheric motion is driven from within. The hexagon may be, in part, a window into this internal energy heat rising from the planet's core. Channeled by rotation and atmospheric flows into a stable, geometric form. Even more intriguing is the possibility that the hexagon might extend much deeper than previously thought. Some models suggest that the storm could reach hundreds or even thousands of kilometers into Saturn's atmosphere. If true, the visible hexagon might be only the top layer of a vast, cylindrical structure spinning deep within the planet. This vertical dimension could explain its remarkable stability. A deep-rooted storm is harder to disrupt, like a massive pillar anchored far below the surface. The central vortex of the hexagon also demands attention. Cassini's close images revealed swirling cloud layers, bright and dark bands, and an eerie, almost perfectly circular eye. The vortex rotates faster than many surrounding winds, suggesting powerful vertical motions. It is like a gigantic planetary whirlpool, an atmospheric drain pulling gases downward into Saturn's depths. Nothing on Earth compares to this strange, serene, and violent region at the heart of a geometric storm. When Cassini eventually ended its mission by diving into Saturn, scientists hoped its final data would reveal more about the hexagon's structure. Although the spacecraft did not plunge directly through the storm, its measurements of Saturn's gravity, magnetic field, and atmospheric density helped refine models of the planet's interior. Yet even with this information, the hexagon remains only partially understood, a symbol of how much of Saturn's nature is still hidden from view. As astronomers look ahead to the next generation of missions, the hexagon remains a prime target. Future spacecraft may carry instruments capable of probing deeper into Saturn's atmosphere, mapping its structure with unprecedented resolution. Others may analyze the composition of the clouds or measure subtle variations in wind speed. Perhaps one day, a probe might even descend directly into the hexagon, plunging through its towering walls of wind, seeking answers in the swirling darkness. But until then, the hexagon continues its silent rotation, carving its path through the golden clouds at the roof of Saturn. It is a reminder that our universe is not only governed by laws of physics, but also capable of producing wonders that challenge our imagination. Whether one views it as a quirk of atmospheric dynamics, a natural polygonal resonance, or a cosmic masterpiece shaped by unseen forces, the hexagon stands as one of the most extraordinary features in the solar system. As we push deeper into the mystery of Saturn's hexagon, we reach a point where science and wonder begin to blur into one another. The phenomenon stands at the intersection of what we can explain and what still escapes us. Even with decades of observations, laboratory experiments, and increasingly complex simulations, the hexagon remains a riddle carved into the atmosphere of a gas giant, a shape that seems to pulse with the hidden mathematics of the universe. When we look at it from afar, through the eyes of Hubble, or the long-distance gaze of Cassini, we see something that feels almost alien in its perfection. Its sides are straight, its angles crisp. It holds its form through seasons, storms, and shifts in sunlight. It is as if Saturn's pole were a canvas on which nature has decided to draw a piece of pure geometry. And yet, this shape is not static. Beneath the perfect lines, Saturn's atmosphere seethes with motion. The winds that form the hexagon twist, collide, and ripple. Hidden beneath the cloud tops, deeper currents carry heat upward from Saturn's core, feeding the engine of the vortex. Temperature gradients shift slowly as the planet experiences its decades-long seasons. Chemical reactions in the high atmosphere weave hazes, dyes, and subtle color changes into the massive structure. The hexagon is not a rigid object but a living, breathing system, constantly in transformation even as its overall shape persists. In many ways, it resembles a cosmic heartbeat, a rhythm maintained across generations of human observers, each passing the mystery to the next. Voyager saw the hexagon more than 40 years ago. Cassini watched it in unimaginable detail, and future telescopes or spacecraft will likely see it again, still revolving with the same elegance, still refusing to dissolve into chaos. But the true scale of time for the hexagon stretches far beyond a human lifetime. For all we know, the storm could have existed centuries before Voyager, and it might remain centuries after our technology has moved on to new frontiers. Saturn rotates, years pass, and the hexagon follows the rhythm of a clock we do not fully understand. One of the most profound realizations about the hexagon is that it challenges our very assumptions about what atmospheres can do. On Earth, weather is messy, jet streams twist unpredictably, hurricanes form spirals, and storm systems rarely stay intact for long. Even Jupiter's Great Red Spot, massive and ancient, has been shrinking and shifting over the decades. Yet Saturn's hexagon remains an atmospheric sculpture that combines fluid chaos with geometric order. This raises philosophical questions as much as scientific ones. How can a storm maintain such perfection for so long? Why does nature favor geometry here, in this distant place, when it avoids such precision in our own skies? What does the hexagon reveal about the deeper tendencies of planetary atmospheres, or perhaps even about the underlying structure of physical laws themselves? In the search for answers, scientists continue to explore Saturn's behavior with new tools. Data archives from Cassini still contain secrets waiting to be uncovered. Computer models grow more advanced every year, able to simulate fluid dynamics on scales once considered impossible. Earth-based telescopes sharpen their views as technology improves. With each new attempt to understand the hexagon, we learn something not only about Saturn, but about the nature of complexity. Some researchers propose that the hexagon might be a form of atmospheric self-organization, a phenomenon in which systems naturally settle into ordered structures when energy flows through them. Patterns like honeycomb lattice, crystal formations, and even biological networks arise through similar processes. Perhaps Saturn's hexagon is another example and expression of the universe's tendency to create order out of chaos when conditions allow. If true, then the hexagon could be a cosmic echo of the same principles that shape snowflakes, seashells, and galaxies. Others take a more computational view, suggesting that the hexagon might represent a stable solution to the equations governing rotating fluids. If the mathematics of Saturn's atmosphere allow for multiple possible states, then the hexagon might be one of the most stable, and once the planet falls into that state, it stays there for as long as the energy input remains steady. From this perspective, the hexagon is not an anomaly but a natural outcome of planetary physics. It only seems strange because Earth rarely, if ever, produces similar conditions. But perhaps the most captivating idea is that the hexagon might not be unique to Saturn at all. If other gas giants in other solar systems have similar rotational speeds, atmospheric compositions, and temperature gradients, they might also host polygonal storms. If we one day observe exoplanets with detailed atmospheric imaging, we might discover similar shapes imprinted onto their poles, other hexagons, perhaps pentagons or heptagons, swirling in alien skies. In this sense, Saturn's hexagon could be the first example of a universal atmospheric phenomenon we are only beginning to understand. As humanity stands at the threshold of new generations of telescopes, James Webb, future megatelescopes on Earth, and next-decade missions to the outer solar system, the hexagon remains a lighthouse for exploration. It calls us back to Saturn, inviting us to look closer, deeper, and with more curiosity than ever before. A new mission to Saturn's atmosphere, equipped with instruments capable of probing turbulent layers, reading chemical signatures, and mapping the depths of the vortex, could transform our understanding of the hexagon forever. But for now, all we can do is watch from afar. There is something poetic about the fact that Saturn, a planet known for its ethereal beauty, harbors such a strange and precise structure. Its rings, composed of icy fragments, orbit like a cosmic halo. Its moons, each unique, carve paths through the planet's magnetosphere. And at the crown of the planet, the hexagon spins a geometric jewel set within a world of storms. The hexagon is, at its heart, a reminder of the limits of our knowledge. It embodies the idea that the universe is not only vast, but profoundly surprising. Every time we think we have mastered the rules, something emerges that forces us to reconsider, rethink, and rediscover. Saturn teaches us humility. It shows us that complexity is not an obstacle to understanding but an invitation to explore. And perhaps that is why the hexagon captivates not only scientists but anyone who gazes at its images. It speaks to a deep human instinct, the fascination with patterns, the search for meaning in structure, the recognition of beauty in order. When we look at the hexagon, we feel something familiar, as if the universe were whispering a truth expressed through shape and motion. It is geometry, symmetry, mystery, and power woven into a single phenomenon. As we imagine the hexagon turning endlessly in the cold light of Saturn's distant sun, it becomes clear that not every mystery needs to be solved to matter. Some mysteries exist to inspire, to push the boundaries of what we believe possible, to call us toward discovery. And Saturn's hexagon does exactly that. It is both a question and an answer, a natural wonder and a scientific challenge, a symbol of how much there is still to learn about the worlds that share our galaxy. In the end, the hexagon stands as one of the solar system's most extraordinary features, a storm shaped like a perfect polygon, spinning at the top of a golden planet hundreds of millions of kilometers away. It is a masterpiece of nature, untouched by human hands, crafted by forces far older than our species. And as long as Saturn continues its path around the sun, the hexagon will endure, reminding us that even in the familiar solar system, the universe still holds wonders that defy expectations and awaken the imagination.